So in this video, we are going to be discussing properties of inequality, so how we can actually solve using inequalities. So you notice that your solving skills that we've been talking about are going to be the exact same here. So this is basically just saying for addition and subtraction, if you add or subtract the same number on both sides of your equation, it's still a true statement for the inequality. So here we have 3 is less than 8. If I add 2 on both sides, 5 is still less than 10. So that's still true. So what that means for us is if I want to move something to the other side of the equation, I can just subtract it or add it on both sides of the equation, and it still holds true for the inequality. So same with subtraction. Same with multiplication and division. I can still multiply and divide on both sides of the inequality and it remains the same. So 7 is less than 12. If I multiply both sides by 3, 21 is still less than 36. Same with division, dividing both sides by the 5 in this example still gives me 3 is less than 7. The thing to note is that this is true for positive numbers only. So as long as they are positive numbers, you add or you multiply and divide just like normal. Addition and subtraction doesn't matter. It works no matter what, but for multiplication and division, as long as it's positive, it is the exact same thing you're used to doing. It's when negatives come into play, so negative multiplication or negative division, that's where we get an issue pops up, but it's something that's easily fixed. So for instance, if I take 8 is greater than 4, which is true, and then I multiply 8 by negative 2 and 4 by negative 2, instead I get negative 16 and negative 8. Now, negative 16 is on the left side of the negative 8 on the number line. So that means negative 16 is actually less than negative 8. So what's going to be important is that anytime that we multiply or divide by a negative number, you are just going to flip the sign. So that means if it was greater than, it's now less than. If it was less than, it's now greater than. So you just flip the sign, so it just points in the other direction. So anytime you multiply or divide by a negative number, so it's what you are doing. You are doing the multiplication on both sides with a negative number, or you are dividing both sides by a negative number, then you flip the sign. So for instance, as a quick example, if I had negative 4x is greater than, say, 2, and I come over here and I'm saying I'm dividing by negative 4 on both sides, the fact that I said this negative is going to affect my sign in the middle. So the left side's still going to cancel like normal, and I get x. Flip this sign is now less than 2 over negative 4, which is negative 1/2. So anytime you divide by a negative, you flip the sign. Anytime you multiply by a negative, you flip the sign. So if instead, let's say I changed this problem around and I had 4x is greater than a negative 2, this time I am dividing by a 4. It doesn't matter that this 2 was negative, that doesn't matter. It's the fact that it was a positive 4 that I divided with, so it actually stays the exact same and is just a negative 1/2 here. So it's what you are dividing or you are multiplying with that's going to decide whether or not you flip the sign. So let's do some examples so you can get used to this. So it's the exact same solving things. So I'm still starting out with, do I have any addition or subtraction? Deal with that. Then do I have any multiplication or division? So forth and so on. So on this problem on the left, we have 45 minus or plus 2b is greater than 61. So I'm going to deal with this 45 first. So I'm going to subtract 45 on both sides since it was a positive 45. So left side cancels, giving me a positive 2b is greater than 61 minus 45, which is 16. So then I'm going to divide both sides by a positive 2. So since it was a positive 2 I'm dividing with, I'm not going to do anything with that side sign, and 16 divided by 2 is just 8. So exact same solving thing. So there's no difference as with positive numbers of what you've been doing. So now let's look at the next example. So I have x plus 5 divided by negative 2 is greater than 3. So right off the bat, I see that I have a binomial in a fraction. So I'm going to put that in parentheses. So that's telling me the first thing I need to do is I need to get rid of this negative 2 that's being divided with. So the opposite of division is multiplication. So I'm going to multiply both sides by a negative 2. I just said I am multiplying by a negative 2. So that means I need to change this sign. Let me put them in highlighters. So because I am multiplying by that negative 2, I need to flip the sign. So these still cancel, leaving me with that x plus 5 on the left. I'm going to flip the sign from a greater than to a less than sign, and 3 times negative 2 is negative 6. So that is the only new thing when I am solving for these inequalities. Anytime I multiply or I divide by a negative, I need to flip the sign. So all that I have left is to subtract 5 on both sides, and I am left with x is less than negative 11. So again, subtraction and addition aren't going to change the sign. It's only multiplication and division when it's with a negative number. So my final answer is x is less than negative 11. So let's do one more. So here I have 2x minus 7 is less than or equal to 5 plus 2x. So I see I have variables on both sides of the equation, so I'm going to start by getting them on the same side. So I'm going to move this positive 2x on the right to the left. So since it was a positive 2x, I'm going to subtract 2x on both sides. So on the right side, 2x minus 2x cancels. On the left side, 2x minus 2x also cancels. So now I'm just left with negative 7 is less than 5. I don't have a variable anymore. So this is important. Anytime you don't have a variable, so no more variable, you need to ask yourself. So ask yourself, is it a true statement? So is negative 7 less than or equal to 5? If it is, so if this is true, then what that means is this is all solutions. So because this is true, it is all solutions. If it is not, so if it's so true statement means all solutions. A false statement means no solutions. So what all solutions means, sometimes you may see it as infinite solutions. But infinite solutions with inequalities doesn't really make sense. So we just say all solutions or all real numbers, all real solutions. You may also see it written with a double bar R. All of these are going to mean the same thing. It just means that no matter what we substitute in for x, it will always be true. So that's why it's all solutions, all real solutions, or that double bar R. If it is a false statement, so something like, I don't know, 5 is greater than 10, that's a false statement. That means that it's no solutions. It means that whatever we plug in will never work. It doesn't matter what we try, it will never be a solution here. So that's anytime all of your variables cancel after you started with variables to begin with. So here my x's all canceled away, leaving me with just -7 is less than or equal to 5. So then I just had to ask myself, is that true? If it is, infinite solutions, or all real solutions. If it's false, then there's no solutions. So here are 2 for you to try. So solve these inequalities. So the first example, you should have had m is less than 9/2. And on the second one, you should have had no solutions.